Hey everybody, today we will do another problem and we will continue on the calculus 3 or multivariable calculus. We will use, we will do the dot product, right? Continue with the dot product of all problems. And we will do something that is called angle between two vectors, right? So that's what we're doing. We do angle between two vectors. Right? So we do angle between two vectors, right? So okay, so when we do this, what are we actually looking for? Obviously, we're looking for the angle, right? And let me clarify something. Last time I said that actually, let me rephrase it. Let me make it clear, right? Because I was correct. I was reading the book, but I was kind of rewording the stuff around too a little bit. Okay, when you're doing vectors, when you're doing the dot product, you will have a problem that you will have an angle. You will have an angle between two vectors, right? But that doesn't mean, again, that does not mean that the result will have an angle on it. See, you will not have an angle on the answer. That's what I'm trying to say. On the final result, the final result is always going to be on a scalar, right? So that's what we're doing today. So we do it. Um, so we do it. We find the angle, right? Actually, yeah, I guess we can say that. We can say finding the angle between two vectors. All right. So find the angle between two vectors, right? Okay. So how can that be possible, right? Let's say, for example, I have vector u and v, right? Let's say, for example, I have vector u and v, right? And then I do vector okay. So let's call this vector v. Let's call this vector u. Now, notice that I have and let's call this point right here origin. Right? So right, so this is the origin, right? Now let me do this. All right. Notice that I have vector u, vector v, and I have some type of angle here, right? And we call this angle theta, right? So basically, we can take the difference between u and v, right? And we can say u minus v is equal to this length, right? Or you can say v minus u. I think it's better v minus u. V minus u, right? Okay. So that's basically, we find the angle between those two vectors, right? U and v, right? And that would be the angle of those two vectors. Okay, so let's get started, right? So, with that being said, the formula that they have the formula is called cosine of theta equal to u dot v, u is equal to u dot v over the magnitude of u times the magnitude of v. Right, so that's the formula that we're using. So, okay, so let's do an example real quick. So the example that we're doing, also they have another definition of orthogonal vectors. They say that, okay, so they say that a vector is orthogonal orthogonal vector is orthogonal, right? When okay, I will say if a vector is orthogonal if u dot v equals 0. All right, so they have that property there. I don't know if I'm going to use it, but they still have this property. A vector or you can say vectors are orthogonal, right? If the dot product of the two vectors u and v equals 0, right? Okay, so let's do an example real quick. Okay, so Okay, so this is example. In this case, we have u equal to vector 3, negative 2, 3, comma, negative, make sure that I get this, 1, comma, 2, right? And then in vector v, okay, and w, vector w, okay, in vector w equal 1, 1, dot 1, comma, 1, negative 1, right? And then negative 2. Actually, but I have a b between there, so I gotta do b. I'm sorry. I gotta do b. So gotta be, and then I have, so b is, and then b they have, yeah, so they have still vector like this, right? So 4, negative 4, comma, 0, comma, 2, right? So that's b. And then it's z, and then they have a z equal, c is equal to 2, 0, 1. 2, comma, 0, comma, negative, I think it's negative 1. Yes, it's negative 1. Right? Now, I think they have another one. No, that's it. It says, find the angle between each pair of vectors, right? Find the angle. Find the angle between each pair of vectors. Right? So that's what they want us to do. Right? So, okay, so let's get it started. Right? So let's start with u and v first. Okay? U and v, and then we'll go from there. Okay, so first of all, we need to do the dot product, right? So we need to do the dot product first, right? So when I do the dot product of u and v, right? So I'm going to do what? I'm going to do the product and then take the magnitude of each vector, right? And then I have to, that is going to give me this number, right? When I do that, right, I'm going to get that angle, right? So, but I have to do the inverse. So I got to do take the inverse of the cosine, right? So that's part of the process, right? So, okay, so let's start with u and v, right? So cosine of theta is equal to what? Is equal to the dot product of 3, negative 1, comma, negative 2, right? And that dotted with with negative 4, 0, 2, right? And now we need to take the magnitude of that, right? So the magnitude of U and V here, right? So the magnitude of U and V. Okay, so if I do that, I'm going to get what? Cosine of theta. If I do this, it's going to be what? It's going to be negative 12, right? And then plus this and this is going to be 0, of course, right? This times this is going to be 0. This times this is going to be, I hope I get, yeah, going to be 4. Right? Now, I did this. Now I got to do the bottom. Right? Now I got to take the magnitude of each. So remember, I'm taking the magnitude of this. Right? So U, let me just do separate here. The magnitude of V is equal to what? We say last time, right? That is equal to whatever this is a square each term and take the square root of it. So 3 squared plus negative 1 squared plus 2 squared. So V is equal to 9 plus 1 plus 2 under the square root, and I get V is equal to what? Is equal to the square root of 12, right? In this part, just in that part. Right? Okay, so now let me do V. So V, I'm taking the square root of V now. I'm sorry, this was U. This was U. Now let's do V. V is going to be equal to what? It's going to be equal to 4, negative 4 squared plus 0 squared plus 2 squared. So V you squared, the square negative, giving you a positive. So it's going to be equal to the square root of 16 plus, this is 0, and this is nothing but 4. So V is going to be equal to the square root of 20. Okay. Square root of 20. Now I got to put those underneath here. I got to put this and this underneath, right? So when I do that, I get, actually, I am wondering how this is 9, this is negative 1, and this is 4. Right? So this is 14. Here you go. Okay? So now I gotta put those over here, right? And I said the square root of 14 times the square root of 20. Right? So now notice that what I can do here, I can take the square root, I can factor this and take the square root of 2 out. I can factor it by 4 and take the square root of 2. The square root of 4, which is 2. Yeah. Yeah. So I can do that. So what I can do here, I can take the square root, I can factor this out, right? Let me just erase this. So, and at the same time, I can just add this, right? So this is going to be negative 8 over that, right? 14 and the square root of 20, right? So now that I have this, right, I can actually work with this and factor out, and I can say cosine of theta is equal to what? It's equal to negative 8 over, right? If I factor out the 20, this is going to be what? This is going to be, it's going to be the square root of 14, and then the square root of 4 times 5, right? Why? Why the 4 times 5? Because I factor it out. It's 20, so I factor out 4, right? And then I can take the square root of 4, which is what? Which is negative 8 over, if I take the square root of 4, this is going to jump over here, and it's going to be, and this is going to be what? It's going to be nothing but 2 times the square root of 14 times the square root of 5. Okay. Notice that I have a 2 and an 8. 2 and an 8, right? So here I can actually divide 2 goes into 8 how many times? It goes 4 times, and I am keeping the sign, and that is negative 4. And then this and this, right? This and this, I can multiply, and it's equal to the square root of 7. I multiply it times this, it gives me the square root of 20. This cancel out by negative 4. I want to make sure that everything is clear what I've done here, right? Okay, so this number right here, this number, I'm going to use that to take the inverse. I'm going to use it to take the inverse function because I need the angle, right? I need cosine of theta is equal to negative 4 over the square root of 70. If I take the inverse of that, it's going to be cosine inverse so now theta is equal to inverse cosine of what? Inverse cosine of negative 4 over the square root of 70, right? And then when I do that, that is going to be, so let's do the square root of 70 first, right? In the calculator, right? That is equal to negative 4 over 8, 3, 6, right? Now, if I take this, if I do the inverse of that, I do theta is equal to cosine inverse of that is equal to negative 4 over 8.366, right? I do the inverse of that, and that is equal to, if I do that, negative 4 divided by the answer, right? And then I do cosine inverse of that, and it's equal to 118.56 degrees, right? So now that is the answer in degrees, right? The book just radians. I mean, you can use radians too. It doesn't really matter. I mean, all you have to do is just change your calculator to the radians mode. You will get, if you do that, you will get about 2 point, this is equivalent to 2.069 radians, right? So if I change the mode of that, for that just to prove it that it's the same thing, right? So, and I do second, and I do cosine of negative 0.47. I said that did not change. Why is not? Okay. Okay, because I have to be in radians. Let's see. So inverse cosine of negative 0.47. Here you go. 0.69. 2.069 radians. Okay, so that's one of the answers, right? Okay, so now you know that I am getting an angle between two vectors, right? But again, I am doing an angle, right? This is not a vector because it doesn't have a number that tells me that it has is going 35 miles due north, in this many degrees, right? It doesn't say anything about that. It's just a plain number, which is basically a measurement, right? Degrees and radians, and that's it. I mean, basically, how we handle this type of problem, right? Now, we can do now UW. Let's do UW quick. So we did that, right? So now let's do this. So let's do part B, right? So that was part 8. Part B, right? Part B says that we need to do U and W, right? Yes, UW, right? So I'm doing U, and I am doing between, did I put W here? I don't think I did. I don't think I did. And W, let me just put it right here. W is, I had it, but I erased it. So it's 1, comma 1, I'm a negative 1, comma, negative 1, and then comma, negative 2, comma, negative 2. Right? Okay, so let's do W, right? So let's do W and U dot W, which is what? Which is cosine of data is equal to what? It's going to equal to, using the formula, it's going to be that W, which is going to be 3, comma, 1, negative 1, comma 2, dotted with what? 1, comma, negative 1, comma, negative 2. Okay, so we do that, the data. When I do this, it's going to be 3. When I do this, it's going to be plus what? This time this is going to be a positive plus 1. When I do this time this is going to be a negative, so I got a minus 4. So, and I do that, and that is going to be equal to 1. Actually, 0? Really? That would make a lot of sense, but let's see. I guess it does. Right? So it's 0. So in this case, we have a situation that this vector is orthogonal, right? Why? Because you got 0. We dotted W dot V, and it's going to be 0. So in this case, it's orthogonal, right? So that's the answer for that, right? That was pretty easy. Okay, so we got part B. Now, but also remember, so here's when this happened, right? So we know that when this is equal to 0, then this means this at the origin, right? At the origin right here, right? What does that mean? What is this angle, right? This is 90 degrees, or pi over 2 in radius. Right? So that's how this is it. So this is equal to theta. We still have an angle, but the angle is right at the origin, so basically it's a 90 degree, so it's pi over 2. Okay, so we have that, right? So B is we have orthogonal vectors, right? Okay, let's do part, real quick, part C. Let's do part C. So part C, we know that part C, we do V dot C. Now, we're doing V dot Z. So we do cosine of theta is equal to it's going to be equal to V dot Z, negative 4, comma 0, comma 2, dot with that, right? So dot Z, which is, you know what? Let me just write the formula, I think. So it's V dotted with Z under its respective magnitudes, and I get what? I get Z, right? With this, I get what? I get cosine of theta is equal to what? Is equal to V dot Z, which is negative 4, comma 0, comma 2, times 2, comma 0, comma negative 1. All over the magnitude of that, right? There's two magnitudes, right? Now, here, I'm going to do the following. I am going to just do the math here, and it's going to be equal to what? This is equal to negative 8 plus this times this, so I got 0, right? And this times this is negative 2. Negative 2. Right? So technically that is 10. That is, did I copy this correctly? No, I did not. No. Yes, I did. This is 2, comma, 0, comma, negative 1. So, so this and this give me negative 8. This and this is obvious, the 0. This and this is negative 2, which is going to be negative 10, right? So it's negative 10, right? Okay, so that's fair enough. That should be negative 10 on top. Now, when I do the bottom here, I need to do the magnitudes of this, right? So let me erase. Let me just do it here, hopefully. Okay, so, let me just write this down. So A, part A was 118. Okay, O, 2.069 rads, right? And V, we say that was orthogonal. All right, and we try to find Z now. So let me just erase this. So I have more room here. Okay, so here I know there's negative 10, right? At the bottom. Okay, so let me just do this separate again. So I gotta do V, right? So the square root of that is going to be what? Square root of V is going to be 4, negative 4, square plus 0, square plus 2 square. So V is going to be equal to, it's going to be equal to the square root of 16 plus 4, which is going to be square root of 20 again. Right, so that's the square root of 20. So now we do Z is going to be equal to the square root of 2 squared plus 0 squared plus 1 plus negative 1 plus negative 1 squared, which is going to be 5. Right? Okay. So now I am doing this the same thing again, and we found that out before that. Actually, this is going to be a little different. Okay, this is done. There's nothing I can do with this, but I can do something with this, right? So in the case of this, right? So I do V is equal to 20, right? Again, I do 20, so I do 5, or I do 4 times 5, right? Take the square root of that, and I get that V is equal to 2 radical 5. Okay, so I have these numbers that I can work with. All I did, I bring this number that I got from here to here, and simplify, right? Okay, now I have this number and I have this number. Now I can actually do this and put these numbers here. So I can actually do 2 rad 5 times 2 rad 5. All right, so now when I do this, notice that I have a 10 and I have a 2. So again, the simple mathematics is playing a role here. So it's really helpful to understand what cancels here, so I can actually cancel the stuff out, so I get small numbers. It's always, always, always better to get the number to the simple terms so you can understand better what's going on. So I get what? I get cosine of theta, right? This cancel by 1, that cancel by 5. See that? So now I get what? I get negative 5 over this times this is going to be equal to 25, right? So now, if I do the inverse cosine of that, and I do theta is equal to what? The inverse cosine of negative 5 over the square root of 5, right? So take the inverse cosine of that, and that will give me the angle between those. So actually, they did something. Okay, what I did is valid too. Huh. Because if I take the square root of this, look at this. Okay, let me just do this. Take the square root of the bottom. What do you get? You get cosine of theta is equal to 1, right? Negative 5. Take the square root of that, right? So 5 over 5, which is equal to negative 1. Right? So, with that being said, there is no angle because Z is in parallel in this case. Yeah, because that's the value of negative 5. Yeah, because it's so if we okay, so in this case, because we got a negative 1, let me just erase this because okay, just be clear in this. Because we got negative 1, where that data is equal to negative 1. Well, the only place where data is equal to negative 1 is in 2 pi. Actually, not a pi. Yes, data is equal to where pi is 180 degrees. Right? So technically, that's it. So pi is equal to data is equal to pi, which is equal to 80 degrees, which means those are parallel. Those vectors are in parallel. So here is 90 and here is 180. So technically, those vectors are like this in parallel. That's why they don't have any angle, right? So because again, this is 90 degrees. This is 90 degrees, all pi over 2, and this over here is just 180 degrees, all pi, right? So that's why this is in this case the angle is C. We found out that we didn't have to do too much in this case, just we found out that is in this case will be pi, right? So those are the answers. Right? Okay, I think that has been everything for today. On this topic, I will continue probably doing review a little more areas of the dot product, and then eventually we'll jump into the cross product. Thank you for watching. Remember, subscribe, like, and share. And just also, if you want, you can leave me a comment. Thank you for watching.